To continue our geometry unit for Outcome G, we're going to start looking at some graph transformations. And transformation is just a big term for any time we change something. So in our case, we're going to be changing shapes on a graph, possibly lines or points as well. There's 4 transformations we're going to be learning about. Today in this video, you're going to see 2 of them. And the 2 we're going to see are translation and reflection. So what you will need is 1 page in your mini geometry booklet for translation with examples, and then 1 page for reflection when we get there. So take a second to copy this down on the next page in your mini geometry book, translation. You may have heard it called a slide before. That's typically how we refer to it in some of the younger grades. And what it means is that the figure that we're working with, it doesn't turn or flip on a graph. It's simply just sliding or moving to a new spot without adjusting in any way, shape, or form. So when I'm looking at a translation, you can copy these down without the actual graph on it in the background if you'd like. Sorry, just trying to get a zoom here. So what you're going to notice with these graphs is that we have an original figure, and that's the one we're starting with. So sometimes it's already graphed, sometimes they give you the points and they ask you to graph it. And then after we've done the movement that they're looking for, we have something called the image, and that's the new picture. And you're going to see it labeled with these apostrophes next to the letters. And the way we refer to that is prime. So this would be A prime, B prime, and C prime. And it really serves no purpose other than just showing us which one is the new picture versus which one was the original. So you're going to see me using the letters O and I, such as I did over there, just to refer to which is the first one that we're working with and which is the new one. In this picture, we can see that triangle ABC was slid down to this new triangle A prime, B prime, C prime. I didn't turn it at all, it didn't flip, it's just simply the exact same pictures, letters lined up, not in new spots, but it's in a new place on the graph. So before, you may have seen this referred to as, let me zoom in a little so we can see the numbers. For example, here we have point B, which is at 8 on the y-axis, and I slid it down to -1 on the y-axis. So it didn't move over at all, it just moved up and down. And for that, we may have said this figure moves down, well, from 8 to -1, that would be 9 jumps down. And that would be really all we said about it. The new way we're going to look at it is deciding what our movement looks like in the ordered pair form. So if I go back to translation, we have 2 ways that we can move on a graph. We can move left and right, and that would be change to my x coordinate. And we can move up and down, and that would be changed to the y coordinate. Okay, so going back to this now, instead of just saying down 9, you're going to see it labeled this way quite a bit. And I'll zoom in again so you can see. I'm going to write it below the picture I just did. Down 9, well, my y-axis is my up and down. So normally we'd have x, comma y. And notice that I'm spreading it out in the ordered pair here, because we're going to show what the change is. I didn't move this graph left or right, so there's no change to x. So x stays x. My y I did change. I moved it down 9. If I'm moving down 9, my number is getting smaller. So that is subtraction. So y, all my y points go to y minus 9. And that's a little sloppy. I'll rewrite it. X stays X. There's no left or right movement with my triangle. And X represents the left and right change. But my Y changed to go down 9. So again, each of these points, if I counted, it would be 9 jumps down to get to the other. And what's new from what you've learned before is this labeling system. So we're going to be using it from here on out when we're talking about really anything, translations, reflections, so on. So let's look at this one. Same idea. If I look from my original to my image, I've gone to the left 1, 2, 3, 4, 5, 6, should be 8. I think I miscounted. It should be 8 to the left because I'm going from 1 to -7. So I'm going to write that down just to keep track. I moved left 8, and I go up from D to D prime. It goes up from 2 up to 7. So that's up 5. And again, before this would have been okay enough to write down for a translation. But since we're using our new system, left has to do with X. And since I'm going to the left, my numbers are getting smaller. So it would be X minus. And up 5, that has to do with my Y axis. And since I'm going up, the numbers are getting larger. So that's going to be plus. So when I rewrite this now below, to show what my movement was, my original X points are changing to go left 8 from where they started. And my original Y points change to go up 5. So that is how I would write out my new translation. Okay, let's look at reflection quickly. Reflection tends to not be quite as difficult, but there are a couple rules. So when we're talking about a reflection, we're talking about a flip of a picture. And that's the way you may have seen it labeled before. So a figure is a mirror image of itself over a line of symmetry. It's usually the X or Y axis. Other times it could be another line, but we're going to refer to the X and Y axis for what we're doing. And then there's some rules here. And this would go on the next page in your mini geometry book. So reflection over the x-axis, we're flipping it over that across line. So that means my x's don't change. I'm not moving it left or right. I'm moving it up and down. So my x stays x, and my y becomes the opposite of y. We're not going to read that as negative y, because if we already are starting with a negative number, it would be the opposite of a negative, which would become positive. So we're going to make sure we read that as the opposite of y. Same thing if I'm going over the y-axis. So in this case, I am moving left and right if I'm flipping over that up and down line. So my original would be xy, and in this case, x changes to the opposite sign, and y would stay the same. Let's look at some examples of that. Okay, so here we have a few. And I'm going to show you how easy it is to implement the rules once we know them. So in my original picture, I have H, J, K, sorry, I'm not sure why that's so blurry, H, J, K, and I labeled it for you just to save time. Now when I flip it, I know it's a flip because my J flipped over the x-axis, my K flipped over the x-axis, my H, same, over the x-axis. And my rule said when I flip over the x-axis, all my x's should stay the same. So that saves me time. All of my x coordinates here stay exactly the same, 2, 7, and 2. There was no movement left or right. It was just up and down. But all of my y's changed to the opposite. So I had a positive 9, that becomes a negative 9. I had a positive 3, negative 3, positive 3, negative 3 again. And if I were to actually go and look at this, those are the coordinates. So I could do it by looking at it on the graph or by using my rule and simply just changing one to the opposite sign. We have the same thing here. Rectangle LMNP. I know it's a reflection because it's a mirror image. If I fold it on the y-axis right there, my p's would line up, n's, so on and so forth. So again, I laid out the points for you to save time, but since we're going over the y-axis, we're moving left and right. That means all of my y coordinates stay the same because we're not moving up or down, but my x's change to the opposite. So instead of negative 8, 6, x changes opposite, I have positive 8, 6. Negative 8, 4 changes to positive 8, 4. Negative 2, 4 changes to 2, 4. Negative 2, 6 changes to 2, 6. A little easier to think about, but the way we wrote out the rule is really what we're going to be focusing on, this little bit at the bottom here that you copied. Okay? Tonight, you have 2 questions to go into your question section. First one, suppose we have triangle ABC with the ordered pair points as labeled. A is 1, 1, B is 3, 4, C is 5, 2. And we're translating it using this rule right here. So x changes to x plus 3, y changes to y minus 2. Please write the new coordinates of image A prime, B prime, C prime. Secondly, number 2, we have triangle DEF, and it's going to be reflected over the y-axis. So we're going to give the new coordinates of image, triangle image D prime, E prime, F prime. So in this case, we're going to say that D is negative 2, negative 1. We'll say that E is at 0, what should we go with? We'll go with negative 5. And we'll say that F is at negative 4, negative 5. If you'd like to draw these out, you're more than welcome. Otherwise, just use the rules that are given to you. So rule for translation, and we know our rules for any reflection, X or Y. And just write out your new points. Be ready to discuss tomorrow.